Good afternoon from my side, and thank you for the invitation to present the Inframix project in this conference. My name is Martin Dirnweber. I'm working for Austria-Tech and was the project manager of the Inframix project. I will start with some basic information on the project. 11 partners from 4 European countries were working in the Inframix project. The project was running for 3 years and has been finished some months ago in May. It was funded by the European Commission and had a budget of about 5 million euro. The focus of the Inframix project was the transition period, where we will have both automated and conventional vehicles on the road. We expect that if no measures are taken, efficiency and safety of the traffic system will decrease. The main objective of Inframix was to design, upgrade, adapt, and test both physical and digital elements of the road infrastructure to achieve a hybrid road infrastructure for future automated transport systems. The Inframix project has focused on the motorway environment, and the work was done on the basis of 3 scenarios. The first one was to dynamically dedicate a lane to automated vehicles to improve safety in mixed traffic environment. The second scenario was roadwork zones, which are a key area concerning road safety. And the third scenario are bottlenecks, for which measures have been developed to improve efficiency. In order to achieve the objectives, the project partners have carried out several activities which I have clustered in 3 areas. The first pillar is the development of solutions. Inframix partners have developed estimation algorithms, traffic control strategies to support and manage mixed vehicle traffic situations, as well as the digital and physical infrastructure elements required to realize the strategies. In order to facilitate the evaluation of the developed measures, since there are not enough automated vehicles available, proper simulation environments have been set up, but also real-world tests have been carried out. And based on the outcomes of the evaluation activities and the learning in development and implementation, recommendations have been provided. The highest visibility in this area has the infrastructure classification scheme ISAT. In all these areas, results have been achieved, and I will go through these results in the rest of the presentation. 4 traffic control algorithms have been developed for mixed vehicle traffic situations: dynamic lane assignment, ACC parameter adaptation for adjusting the desired time gap to the leading vehicle, lane change advice to connected vehicles at bottlenecks, and a mainstream traffic flow control via VSL. Traffic estimators have been developed to obtain the input information for the traffic controllers. These estimators use information from spot sensors and from connected vehicles. These control algorithms have been tested, and very promising evaluation results have been achieved. Suitable simulation environments have been a key element of the project. Microscopic and submicroscopic simulation environments have been coupled to combine the advantages of both areas. The focus of the microscopic simulation environment were the physical and digital infrastructure elements, whereas the submicroscopic simulation allowed to go into the details of vehicle dynamics and behavior. In order to further extend the evaluation capabilities, real vehicles driving on an enclosed proving ground have been coupled with a virtual traffic environment, so hybrid testing has been realized. these vehicles have received real CITS messages, and their reaction to these messages and the surrounding virtual traffic has been investigated. The main overall observations were that speed recommendation for connected and automated vehicles have had positive implications in terms of safety. And the lane change recommendations usually led to underutilization of traffic flow efficiency and also created risky traffic situations. Another key element was to provide the infrastructure required to address both connected and conventional vehicles. Within Inframix, vehicles have been addressed by both ITSG5 and cellular communication. New signs, dynamic lane activation and deactivation, have been developed and applied during tests. The application of the new signs, as well as the combination of existing signs, have received very good user acceptance during the Inframix test events. The Inframix system was implemented and tested in test sites in Spain and Austria. Next generation CITS services have been successfully tested in Europe for the first time. On the next slide, I will provide information on the evaluation results. In general, Inframix could show that infrastructure support can improve efficiency and safety of the transport system. So this is a very key result of the project. The evaluation has shown that an increasing penetration rate of automated vehicles will lead to a decrease of traffic efficiency if no measures are taken. It has shown that there is a positive impact in safety for speed recommendations, and the ACC time cap controller could improve efficiency in case of delays of up to some 50%, and this would work even for low RSU coverage. Speed advices could decrease delay times by 10 to 15%. It has been shown that the positive effect on efficiency could be achieved with about 15 to 20% of communication-capable vehicles, because they influence the whole traffic with their adapted behavior. So this works even with a low coverage of VMS for addressing conventional vehicles. Concerning the traffic estimators, particularly the cross-lane estimator has reached maturity for immediate exploitation. This allows the reduction of the number of spot sensors and therefore a reduction of costs. An important element for infrastructure deployment and for the use of infrastructure support is to provide information on the capabilities of the road infrastructure to support automated vehicles. Therefore, the road classification scheme ISAT has been developed. The scheme classifies infrastructure capabilities in 5 different classes, from Class E for conventional infrastructure with no support for automated driving to Class A, where cooperative driving is supported. The scheme has been discussed in several groups and at several events. It has also been included in the AirTrack Connected Automated Driving Roadmap 2019. Finally, the important question is, what are the next steps until the deployment of Inframix solutions? It's important to integrate the developments with other solutions. Inframix could show that the developed elements work and that they are effective, but these will be part of a larger system for traffic management in future. The tests have to be extended to different scenarios, road types and countries. Also, there are still adaptations required in the legal framework and in standardization. Then, of course, elements have to be deployed. Some of the important elements which are needed to address the vehicles are being deployed already. And what is a key element is the coordination with other stakeholders concerning the extension to future scenarios and the combination with other measures. So, thanks to the funding of the European Commission and the high expertise and commitment of the project partners, important results could be achieved in the InfraMix project. I thank you very much for your attention.